Now that we've created the online plant DAO, let's make this available to our plant service. So the way to do this is we're going to need to add methods to our interface, IPlantDAO. So what I'll do is I'll add a couple of methods. And by the way, one trick we have to keep in mind right now who implements this interface. It's pretty easy to find out. In Eclipse, we can simply click on the interface name and then hold down Control and press T, and it will tell us who implements it. So one little trick. When we add these methods, we're going to also have to add them to the online plant DAO. That would take some work to actually implement because we'd need to wire it up to the real plant places and all that. I'll probably just fill that in with stubs. So what I'll do now is add a couple of methods here. One to save a single specimen and the other to return all specimens. And that way we'll be able to see what specimens we have saved in the database, which ones we've uploaded, so on and so forth. So one nice thing about using an interface is if we do have the interface implemented in multiple classes, we only really need to comment the method in the interface itself. That'll save us a little bit of work. So we'll say public void save specimen, and then that's going to accept our specimen DAO. It will probably throw an exception as well. So let's go ahead and let's go ahead and account for that. Okay, Control-Shift-O to organize imports. Public. Now that's our save method. Okay, so that's going to save or update our specimen. Now let's have a fetch method. So public list specimen, let's make it array list to be consistent. Array list specimen, fetch all specimens. Okay, throws exception. Okay, and there we go. So one will save the specimen, the other will retrieve the specimens. Okay, we'll put some comments here. Save the specimen to the persistence layer. Notice we're not saying database, and that's because this interface is implemented both by our online and our offline DAO. Specimen, what we want to save. Exception in case there is a persistence exception that cannot be handled locally. Okay, fetch all specimens, return all specimens from the persistence layer. Okay, return a collection of specimens. Okay, throws exception in case there is a persistence exception that cannot be handled locally. Okay, I think we're in good shape. And we save. Now, as soon as I save, if you take a look on the navigation view, you'll see that my offline plant DAO and my online plant DAO both now don't compile because I've added two methods to the interface that have not yet been implemented in these concrete classes. So I click on the class, and for the online plant DAO, again, I'm just going to put a dummy implementation in there. In reality, we'd have to do something like this that we did a week or two ago, where we actually use the network and save it over the network. But, you know, we've already been through that. There's nothing new to learn there. So what we'll do is we'll simply stub out the methods for the online plant DAO and leave them as they are. In theory, we could tackle this in a later sprint. We do have to at the very least, we need to put the methods in, which I just did by saying add unimplemented methods. You know, they're not doing anything here. That'll be fine for now. So I go to offline plant DAO, and this is where I'm actually going to do some work. I click on the light bulb again and say add unimplemented methods. Boom, there we go. And now I'm going to go down and go into save specimen. Okay, save specimen will be the first thing we'll implement, the first thing we'll test, because obviously it's once we save something, then we can retrieve it. But without anything saved, there's nothing we can retrieve. And this honestly isn't too hard to implement. First of all, I'm going to take away this comment. Control D in Eclipse will remove one line at a time. What we'll do is we'll say create a content values to hold the data we wish to save. Okay? So, content values equals new content values. Remember from the slides, this Control-Shift-O to automatically import. This is one of those classes that we use to put information into a database. I don't know why they didn't just use hash map, but okay. Now the next thing we need to do is values.put. And notice the signature here. Notice this is an overloaded signature. We start with the string key, and that represents the column names. And then we have a value, which can be a Boolean, a byte, a double, float, and so on and so forth. So the column name has to match what's in the table statement. So what I can do is say put genus, okay, and then say specimen dot get genus. I'm sorry. This is specimen, not plant. So specimen, what's on our specimen table? Plant ID. Ooh, we need to add that to our DTO probably. Latitude, longitude, description, published. So plant ID, okay, and then specimen dot get plant ID. There we go. So we're associating the plant ID from the specimen with the column in the database. Now, one thing I'll tell you we should do is we should really make a constant out of this because we're referring to it in two places, and we'll probably refer to it in more than two places over time. See, here it is in our save statement. Here it is in our create table statement as well. So we're going to be much less error prone if we make a constant and just refer to that constant. Okay? Also, if we ever change this column name, we only need to change it in one place. Also, when we have constants, and I'll show you this in a minute, with Eclipse we can do a reference search, and we can find everything that's referencing that constant. So I'm going to right-click, and I'm going to choose Refactor, and this might be slightly off your screen, but Refactor and Extract Constant. And Eclipse is smart enough to name this in a smart manner, plant_ID, all capitalized. That is typically how we name constants in Java. Constants are typically public or private, static, and final, which means once initialized, their values cannot be changed. So constant name, plant ID, okay? So all uppercase, separate words with an underscore. Private's fine. Since this is going to be final, I can make it public as well. There's no harm in that because it can't be changed externally. So there we go, plant ID. And now what I'm going to do is I am going to insert that. I'm going to replace this static string plant ID. We'll take that out. And instead of that, 2 double quotes, 2 pluses, and put the constant in instead. So now we are certain that our column names match because what we're using here, we're also using here. Furthermore, it's very self-descriptive. Okay, when we see this constant, again, in Eclipse, we can right-click and do a references search, references, and workspace. That will actually show us every class where this constant is referenced, if it's referenced in multiple classes. Much better to do that than to use just a string literal. String literal you can't do a reference search on. Okay. So plant ID, there we go, we got our plant ID. We won't worry about the specimen ID, that's auto-generated anyway. What else do we have? So we have latitude, longitude, description, okay. So let's go ahead here and values.put, okay. Latitude, specimen, get latitude, okay. And of course we'll make constants out of each of these, okay. Right-click, refactor. We could do this ourselves. It's just the extract constant does a lot of work for us. Latitude, there we go. Okay, values.put. Okay, once again, we'll borrow, and I'll go back and fix this. Let's see, first of all, I'm going to recenter so we can see a little more of this on the screen. I'll go back and redo this string up here in just a moment. Redo our create table string. Okay, values put, longitude, specimen dot get longitude. There we go. Values dot put. Who's next? Oh, I need to make a constant out of that, don't I? Okay. Right click, refactor, extract constant. Boom. Yep. Okay. So we have description and published. Okay. Okay. Latitude, longitude. Values put, description, specimen dot get description. Okay, and once again, notice what it does. Not only does it create a constant, but it replaces this string literal with that constant. Okay, extract constant, description. Okay, one moment please. Okay, there we go. Line back up again. Okay, and let's see, we also had published. Okay. Values.put. In this one, we might need to add to the DTO as well. Specimen.get. Yeah, we need to add this one to the DTO. So hold that thought for just a minute. I'm going to go back to my specimen DTO, and we'll add a new attribute. Private Boolean. Well, we'll make this an int. We'll stay consistent. Published. Okay. And we're actually going to default this to 0, meaning it's not published. Right click, refactor. Actually, I'll do it up here. Right click, refactor, or source rather. Generate getters and setters. Published. I click on that, like so. Choose OK. And we're all set. Okay, so now our DTO is up to date. Now back here. Okay, published. Specimen. Dot get published. And there we go. Okay. And we'll do our constant trick. Refactor, extract constant. There we go. Okay, looking good. Now we can go back and we can clean up our SQL statement here. So I'll replace each of these string literals with a constant. Boom plus latitude plus boom text. Okay. Boom boom plus plus longitude. There we go. Plus text. Boom 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 boom. Description. There we go. Okay, it's coming together here. Published. And there we have it. Okay, our create table specimens is now all set and ready to go. You know, one thing I am going to change slightly. I already have a database named Plant Places. I'm going to name this Plant Places Summer 12. There we go. Okay, and save. Okay, now what we need is we need to invoke a method from the superclass called get Writable Database. To be honest, I can just start typing, and in Eclipse I can hold Control and hit space. And if it knows I'm trying to call a method from the superclass, it will autocomplete what I'm typing. So get Writable Database dot insert. Okay, string table. Gosh, we need to make a constant for that, don't we? So specimens. Okay, put that in quotes. We'll make a constant out of that. Okay, refactor, extract constant. Let's call it specimens underscore table. Okay, go up here in our create statement, fix that. Specimens table. Okay, looks great. Okay, null column hack is weird. We just have to give it a column here to use. If we're giving it a null record, It's really strange. I've never seen a good explanation of it. Basically, we just have to put a column in here, a column name. So I'll say latitude. Okay, values is going to be our content values, and we're all set. So there's our insert method, and I'll hit save. Okay. Because I want to make sure I have this create table statement absolutely right, I'm going to go ahead and do the fetch all method before we test this out to make sure I haven't forgotten anything. So next, let's work on the fetch all method. When getting information from the database, we can write a query, run a query, and then we need to get the data out of the query. To do that, we use a cursor object in Android. And the cursor will allow us to get values from a specific column. Curiously, we have to provide it with a column number. We can't provide it with a column name, which in JDBC you can actually do either, but okay, not a problem. So we start counting at 0. We can invoke get string, get short, get long, get double, whatever we wish. So we'll start with our fetch all specimens. We'll start with a SQL statement. We'll just say, string select SQL equals select star from specimens. Well, let's see. Select star from plus specimen. Let's use that constant, specimens table. Okay? Did I spell that? I keep putting a T in specimen. I don't know why. By the way, it's very old school to hard code SQL in a Java class. That's considered not good design, but nonetheless, sometimes it happens. Okay, from that, what we can do is invoke get readable database. Just like we just did get writable database, if we're only reading information, then we can invoke get readable database. And remember the Eclipse trick. If I start typing a method from the superclass that I wish to call, or even one from the local class, I start typing, hold Control and hit space, and it will do an autocomplete. So get readable database dot raw query. Okay, let me do that. Sorry, let me do that again to get the context sensitive help. Raw query. And this raw query can take a string array, which is arguments that can be passed in, kind of like parameterized arguments, but we don't have any. We're just getting all specimens. So raw query, okay, select SQL, and then since we don't have any parameters to pass in, we'll simply pass in null. Or or if we wanted, we could pass new string, a 0 length string. That would be, either one of those would work. This one looks a little cleaner to me. Okay, now one thing very helpful about Eclipse is that if we have a method that returns something, we can hold down Control and hit 1, and it will guess what we're trying to do, and we can choose assign statement to new local variable. In this case, we see that Eclipse automatically saw it wants to return a cursor. Okay, and remember, a cursor is kind of like a result set. Okay, so we'll name it specimen results. Okay, like so. There we go. It automatically saw the get readable database.raw query wants to return a cursor. Let me give us some more space so I can fit more of this on our screen. Okay, now what we need to do, so here, let me put some comments. Okay, we'll say the SQL statement that will fetch specimens. Okay. Run the query. Okay. Now let's say iterate over the query result and populate our specimen objects. Okay. So now what we need to do is we need to iterate. In other words, we need to have a loop, and we need to loop over each of the results in this cursor. Within that, we'll pull out each column individually and populate that column into a specimen. For this, we need to use 4 important methods of the cursor object, or cursor class. Number 1, cursor.getCount. We only want to iterate over a collection of results if we have results. So let's start with an if test. Next, cursor move to first, which means start reading from the very first result of the result set. Next, cursor is after last, which tells us we've reached the end of the results. And finally, cursor move to next, which will tell us to move from the current result to the next result in the collection. So let's start. I'll say see if we have results. If specimen results, I know I'm going to use that a lot, so I'm going to copy it into memory. If specimen results dot get count greater than 0. So we only want to do this activity if we have more than 0, or if we have results. So I will put a curly here. And now we're going to say if we do have results, then move to the first row of the results. Let's see, sorry, paste dot move to first. Okay, there we go. Okay. Now we're ready to iterate over the results. Okay, so while, okay, specimen results is after last. Okay, careful here, because what I'm saying is in a while loop, I want to iterate while a condition is true. This condition that I have right now is going to be false until we reach the last record. So I need to negate it by putting an exclamation first. And in that way, this expression is now going to be true until we reach the last record. Okay? Open curly and close curly. And at the end of the while loop, I'm going to go ahead and put this in now so I don't forget it later. We'll say move to the next record in the results. Okay, and specimen results dot move to next. Okay, now in between these two, we simply need to create and populate a specimen object. We also, one thing we've not done yet, we need to make an array list collection that's going to hold all these specimens. So, array list specimen, all specimens equals new array list specimen. Okay. And then return, instead of null, all specimens. Okay. Return the results. Sorry. Notice that if we don't get any results, we simply return an empty array list. No harm in that. Within the while loop now, we want to create and instantiate a specimen object. So specimen, this specimen equals new specimen. Okay, and now populate it. Populate the specimen object. Okay, this specimen dot set ID. Okay, specimen results dot get column. Dot get int. Okay, and remember we start counting at 0, so there we go. This specimen dot set, shoot, we have to do this in the order that the rows were created in our table, so I need to remember the order is the ID, the plant ID, latitude, longitude, description, published. Okay, the ID, okay, the plant ID, set plant ID, specimen results dot get int. Okay, this time we'll give it a column index of 1. This specimen dot set latitude, I believe latitude was our first. Specimen results dot get, let's see, we made that a string, didn't we? Get string 2. Okay, this specimen, shoot, no, we did make that a double, didn't we? Set longitude. Okay, specimen results get double 3. Okay, let's go up and fix this. Okay, this specimen set, let's see, it was description, specimen results dot get string 4, terminate with a semicolon. Whoops, whoops, one little miskey and I'm way off. Finally, this specimen dot set published specimen results.getInt, and the fifth column finally. Okay, so we're looking pretty good. We're looking pretty good. We also want to now add this specimen to the collection that will get returned. Okay, so all specimens dot add this specimen. And there we go. Okay, we're looking pretty good now. I'm going to double check everything because I know it's very important that we get this set up correctly at first. So let's see, starting with our create table, and then the specimens table constant. Okay, ID primary key auto increment. Make sure that's spelled correctly. Okay, plant ID, which is an int, latitude text, longitude text, description text, and published, which is an int, closed paren, semicolon. That's good. The plant table we're not going to worry too much about yet. I'll just make sure I don't have any crazy misspellings there. That looks good. Okay, I think we're in good shape. And if we wanted, we could actually make these all look like SQL columns that are all caps and underscore between words, but I'll leave that as an activity to the user. So at this point, we look pretty good. Now, what we need to know is, now that we have this in our offline plant DAO, how are we going to call this? And I'll recommend that we call this through our plant service. Okay, so we're going to need to make a little change to the plant service. We're going to need to make a fetch specimen method, and we're also going to need to make a save specimen method. So let me go ahead and add that here. Okay, I'll save. And actually, let me do a quick checkpoint and just look where we are on our Scrum board. Is there anything we can move yet? Okay, create the offline plant DAO class. I'm going to call that done. Create initial schema. Actually, we'll call that verify because we haven't tested it out yet. So let's move both of these to the verify column. Research SQLLite, I'll go ahead and call that done because we did go through our presentation. Create our queries. I'll move that into the verify column again. So we're looking pretty good on our Scrum board here. Things are starting to look pretty good. Okay, so in the IPlantService now, I'm going to say public list specimen fetch specimens. Okay, or we called it, we'll keep it consistent, fetch all specimens, throws exception. Okay, public void save specimen, specimen. There I go again. Throws exception. Okay, Control-Shift-O, automatically organize imports. I'll put some quick and dirty comments here. Okay, fetch all specimens in the database. Okay, return a collection of specimens. Okay, exception, we'll leave that as is. Okay. Save the given specimen. Now, once again, we have a bit of a challenge here, which is that we have the IPlantService, which is implemented both by PlantService stub and PlantService. We already know what the stub does. I'm going to just let those methods, I'm going to leave them empty. Our concern here is for PlantService. So I choose save. I go to PlantService stub. Okay. And I add on implemented methods, and again, we're just going to leave those blank in this case. It's PlantService where I want to make some changes. So PlantService again, I click on the light bulb, say add on implemented methods. Okay, here we go. And now what I can do, because I've declared my plant DAO up here, oh, interestingly, you might remember I started to make an offline plant DAO and we never actually implemented it. Now we can do that. So I have my offline plant DAO. I will have the constructor for PlantService initialize that. Notice that I used the interface type as the variable type, okay? So offline plant DAO equals new offline plant DAO. Okay, so notice we're taking an object of type offline plant DAO, storing it in a variable of the interface type. IPlantDAO. That's fairly common. Our variable type and our object type are different. However, the variable type is an interface that the object type implements. So Control-Shift-O to automatically organize imports. Oh, and I probably should terminate that with a semicolon, not a colon. Try Control-Shift-O again. And what doesn't it like? Oh, I know what it doesn't like. Okay, it needs that, yeah, we're going to have to change this just slightly. It requires that context to create the database, remember? And that context is a superclass of our activity. Where are we going to get that? Because we're not in a UI layer right now. Well, we're going to get that from our activity, and our activity is what calls this constructor. If I go to IPlantService and say open call hierarchy, and by the way, this is one of my favorite things about Eclipse, we see that IPlantService is constructed here in our plant result activity. You see that? And when it's constructed, nothing is passed to that constructor. We're going to change it. We're currently in the plant result activity. Let's do a Control-T and see the type hierarchy. Another one of my favorite things about Eclipse. Control-T will show you all superclasses and subclasses of whatever you have selected. So if we go here, we see plant results activity extends list activity, which extends activity, context theme wrapper, context wrapper, and finally context. And then context extends capital O. So this is a context object. And what I can do is where I call IPlantService, I can simply pass in this. We see that's purple. This represents the current object. Okay, this represents the current object. So I can pass in a reference to the current object and save. Now, since I'm passing in a parameter, my IPlantService constructor must now accept a parameter. So I'll say context, and now Control-Shift-O to organize imports. We can pass that context down to our offline plant DAO. And the offline plant DAO, remember how it uses that context. It takes that context, passes it to the constructor of SQLLite Open Helper, so that SQLLite Open Helper can know where to store our database. So, a long jump in thought there, but needless to say, at the end of the day, everything's working. Okay, so I go back to my IPlantService, and we now have our online and offline DAO constructed. And remember, the idea here is we want to do online first usually, but if an exception is thrown from online that it doesn't have network access, we toggle over to offline. That's how the plant places in real life actually works. For our case though, right now we're going to focus on fetch all specimens. And for this, we're simply going to do a quick call here and say return offline plant DAO dot fetch all specimens. Easy as that. Okay. Remember, no need to comment a method if it's already commented in the interface. That'll take care of it. Save specimen. Once again, offline plant DAO dot save specimen. Exact same thing. So that's quite easy. We now have our IPlantService calling down to the DAO. And the next thing we need is for our activity to now call this specimen. Which activity? Probably the one right here, the very first one that launches. And remember, we have the Save Location button. So this is the screen that we're trying to save. It's going to have a latitude and a longitude and a description. And if we hit Find Specimen, it will also give us a plant ID. So it's the Save Location now that we want to activate, and we want to have call our Save Specimen. Later on, we can do a Show All Locations button as well, and we can have that come to a screen that shows all locations. Okay, so this is the location activity screen, the location finder. I'm going to go back there and I'm going to remember what that button is wired up to. Okay, find specimen, save specimen. We have this going to a save method right now. As I recall, there's not much in there. Okay, we started to do some work here, but we never finished it. So, number one, I need to get a reference to my IPlantService. Let's see if I already have one defined. I'll look up at my attributes. I do not. So we're going to need to define our plant service. We're going to need to create a variable for that. I say private IPlantService. Again, I can't stress enough. We always use the interface type as a variable. That way we can toggle between the stub and the actual implementation. IPlantService, plant service. Okay, like so. And then Control-Shift-O automatically organize imports. Okay. All right, in the onCreate method, here what we'll do is we will initialize our plant service. Okay, actually we don't need to do that absolutely first. Let's go down and, okay, let's go down to about here, okay? Plant service equals new plant service. But remember, this constructor requires an argument gets passed in, okay? Control-Shift-O, organize imports. It requires a context argument. Once again, location finder is an activity, and an activity is a context. So we can simply pass in a reference to the current object. And there we go. Okay, I'm going to terminate the debugger. That's fine. I know this is going to be a big change. Okay, our plant service is now defined, and now in our save method, we can start to make this work. Okay? So, we'll say specimen, this specimen equals new specimen. Okay. Control-Shift-O, organize imports. This specimen dot set latitude. Okay, and we'll say double dot parse double strlat. I'll tell you, if I did have one thing to do over right now, I would make that data type consistent, because I keep toggling back and forth between string and double on these two. I'm really hesitant to use a double because it's a floating point type. But needless to say, here we go. Okay, this specimen, set longitude. Okay, double dot parse double. Okay, strlng. There we go. That'll work. Okay, this specimen, set description. Okay, str description. That one's pretty easy. This we'll leave. We already have that published defaulted to 0, which we're going to say it's not published. We won't set that. One thing we do need to do. Oh shoot. It would be nice if we could get our plant ID, and I see we never fully implemented that, and that might be a little too much to bite off right now, just because we're this lecture's already about 38 minutes. So I'm gonna dummy up the I'm gonna just enter a dummy plant ID now. We can come back and clean that up later. This specimen. By the way, never do that in real life because you'll forget. Set plant ID. We'll just set it to 1 for the moment. Okay, but yeah, we do need to do that, and that is definitely doable. Okay, now let's see. I'll put some comments here. Create and populate our specimen. Okay, and then we'll say save the specimen using the plant service. Now, since the plant service uses both an online and offline DAO, whoops, it's entirely possible that we might not know whether this is getting saved online or this is getting saved to the local database. It doesn't matter. We're abstracted away from that. Nothing here specifically says we're saving either online or saving to the database. Okay, I'm getting an error here. Probably it's because of the exception. So I'm going to choose surround with try catch. I am in a user interface layer. Okay, so this is an appropriate time to show a toast since I'm in a user interface layer. So what I'm going to do, remember how exceptions work. If an exception is thrown, it will skip everything until it finds the match and catch block. So be very scientific on where you put the try and the catch. Don't just put it somewhere to satisfy a red line. Think carefully about what's in a try block and what's in a catch block. For example, this toast.make text says specimen saved. That's only going to appear if the specimen is saved, because if the specimen is not saved, then an exception will be thrown here, and it will skip everything down to the catch block. Okay? This is something I'm going to be looking very closely for on your final assignment. Are exceptions handled well? In other words, if there's something wrong with saving the specimen, it's going to skip what's in blue, jump down here, and then execute the next line down here. If you had a message down here saying the specimen is saved, you might be lying. Because if there were an exception, it would hit the catch block, and then down here it would execute whatever is here. If you're saying here you have a toast that says the specimen is saved, it might not have been saved. You might be lying. So the better place to put it is between the line that's saving the specimen and the catch block. Because if there is an exception, it's then going to skip that specimen saved method. Now, as a courtesy to the user, let's go ahead and let's go ahead and make a toast if the specimen was not saved. We'll say specimen not saved, okay, and then the description, and then we'll say plus message, and we'll print the exception message. Whoops, sorry, e.getMessage, okay, and that looks good. We also might want to do a log.e, this.getClass.getName. Definitely we always want to log. Okay, and then E. We always want to log, Control-Shift-O, because when things go into production, oh, come on. Oh, okay, e.getMessage. See if that'll like that. Okay, because when things go into production, that's when our job gets very intense, because we have to start debugging things that we might not be able to reproduce easily, or we might get an invalid description from the user on what the user was doing at the time. So logs can be a nice safety there that will help us determine what was going on when a problem occurred. Anytime you have an exception block, you should definitely log it. Anytime you have an exception block, do a log.e, and here I'm doing this get class get name, which will tell us what class it was in when the exception happened. Get message gives us the exception message, and then E is the exception object itself. So again, in a 200 level class, I wouldn't expect this level of detail on an assignment, but in a 400 level class, I definitely do. And on the final programming assignment, one thing I'm going to be looking at very closely is how you handled exceptions. So be very careful of that. Okay, with that now, I save, and very nervously, I'm going to debug because we made a lot of changes here. So on offline plant DAO, I'll set a breakpoint on the onCreate, and I'll do one on the save. We haven't called the fetch yet, but I'll go ahead and put one there. IPlantService, nothing really special there. Location finder, I will go, okay, I already have a breakpoint there. With that now, I'm going to launch the debugger. I actually, to save time, I still have the simulator running. So what'll happen is it will just go ahead and pop up the program right here in the simulator. It will still take a few moments, so I'm going to pause the recording and come back once the debugger has launched. Okay, and it's launched. So, okay, let's remember how to make a latitude and longitude. We have to go over in Eclipse and go to the DDMS. Okay, and by the way, there's something in the DDMS we're going to find very handy in a moment, and that is a way to look at our database. Let me scroll down, and we'll go ahead and send a latitude and longitude, and let's see how we did. Did we receive that? Oh, come on. It's going to really disappoint me if that doesn't work. Well, hell. Well, that part we already had running, so now all of a sudden it doesn't want to run. Um, okay, all right, well, I'll tell you what. We'll put in a description. First specimen. A little bit slow, but nonetheless. Now, why in the world is my latitude and longitude not accepting? That's the one part I did take for granted and assume would run. Okay, there we go. Oh, okay. Maybe it's just waiting on a debugger. So we choose yes. It could just be running slowly. That's very possible. Okay. Yep, there we go. It was just waiting on a breakpoint. So I'll go ahead and play through that. And as long as we get, there we go. There we have a latitude and longitude. So now the part that I'm a bit nervous about. Let me go ahead and choose save location. I'm very concerned with putting a string literal to create a table, but we'll go ahead and see what we can do. So I choose save location. Okay, we go to our on-click listener and it chooses save. Let's watch this very carefully. In Eclipse, I choose F5 to step into a method. Okay, we're getting our latitude value, longitude value, description. Okay, we're creating a new specimen, saving those in the specimen. Okay, now we're going to go into the plant service, save specimen. Okay, this takes us to the offline plant DAO, save specimen. Okay, and now we're going to create our content values and populate those. Okay, now I'm going to choose F6. Watch what happens when I choose F6. Okay, this is the first time we've called our database, so look what's happening here. It's creating it called our onCreate, and it's putting our schema information in here. So let's hope we did this right, because this is the one shot we get at creating our schema. So I'm going to F6 and hope I don't get an exception. Ah, looks good so far. Okay, but we're not out of the woods yet. Okay. Still looks pretty good. I don't see, let's see, do I see any indication there was an error? I don't. I'm going to choose F8, which is continue. And let's go back and look at our simulator. Okay. Unfortunately, that message popped up too quickly for me to see. Okay. So, did we successfully save our specimen? Let's go to the DDMS again. Okay. And one handy thing about this is we have this file explorer. Okay, see, remember, I'm in the DDMS view. Let me show that. I'm in the DDMS view. We have this file explorer. I'm going to choose data, and what do we have? It's a little tricky to find this. Data, SD card. I don't think it's under SD card. Under here, it has our database. And what we can do, oh, there it is, data. I know, I remembered it was something goofy like that. Data. And now we have, let's see, here we go, 2012 0715. So 2012, July 15th, which is the day I'm recording this. Let me go under here, databases. Okay, so what's our path? What's our path? In the File Explorer in DDMS, data. The package name where our, now which package name is that? com.plantplacesui. Remember how we sent in the context from Location Finder? And Location Finder is in package com.plantplaces.ui. So this is the package of the context that we provided to SQLLite. Under there, then databases, plant places summer 12. Okay, now that's the database. And given that time, let me see what time it is right now. Right now it is, well, right now the simulator thinks it's 10:39 p.m., even though actually it's 5:39 p.m. where I am in Mexico, which would be 6:39 p.m. in Cincinnati. So, needless to say, given that it created this database, I'm actually quite happy right now. So what I can do is I can look at this database. I can look at anything that is on this. Actually, that reminds me of something else. I can look at anything that is on this simulated SD card or simulated memory. If I just choose this little disk here, okay, that will give me an option to pull this out of the debugger and save it somewhere where I can make use of it. So plant places summer 12. I'm going to put it under C, users, Jones B, and then we'll put it under my documents and my and UC, and then the folder I've created for this class. Okay, and I'll say plant places summer 12 first database. I don't know what extension to give it, so we'll just say .db, and I'm going to copy this so I can remember it later. And I choose save. Now, SQLite, one thing that's kind of handy about SQLite is there is a browser that's available for it, okay? And I will make this available also on Blackboard. It's a very, it's a very kind of rudimentary user interface, but the nice thing is it installs easily. All you have to do is unzip it. And I've unzipped my Okay, if you notice there, the microphone went off. For some reason, with this screen capture software, when I go over and use Windows Explorer, the microphone shuts off occasionally, and what I have to do is I have to pause the recording, basically go back and kick the microphone back on again. So I'll repeat what I said there while the mic was off. I just opened this database, and I'm very happy right now because when I look, I see the tables that I created, specimen and plants, and I see the columns that I created as well. That's really good news. So let me go to Browse Data, and from the drop down I'll choose Specimens, and take a look at that. There we go. Okay? Does that look familiar? Looks very good. I'm very happy. I'm actually really happy now because everything worked just great. Okay? We have our ID, our plant ID, and if we save another one, we'll have an updated plant ID and so on and so forth. So that's the SQLite browser. One important thing to remember is that we have copied the database out of the debugger simulator. So while you can change data in the SQLite browser, it's not going to affect what the phone sees because we're looking at a copy of the data. Okay, similarly, if I update this and say second specimen and then save it, we won't see it in the browser until we go through that exercise of copying the data over again. The truth is, we'll just make a screen to fetch and display these specimens. But I wanted to show you here what the SQLite browser is. And if you're having difficulty with your database, SQLite browser might be a nice thing to use to make sure that everything looks good. So there we go, a nice little development tool. So we know with the DDMS, we can do a few things. We can simulate a GPS, and if I wish, I can send another GPS location in here. Let's see, what Cincinnati is minus 89 longitude and 32 latitude, so I can send that. And I'm going to disable this breakpoint. I think we've seen that one enough. And play. So DDMS will let me do that, and as a matter of fact, since I went ahead and did that, excuse me, since I went ahead and did that, I'll save this specimen as well. Let's see. So we'll have two specimens to look at since I've given this one a new GPS. All right, a little slow response here, so we might come back and, here we go. Okay, are we there? Okay, we'll see how that's doing in a moment. Sometimes it takes a while. Whoop! Sometimes the reaction time isn't very quickly on the debugger. Luckily, it is pretty quick on the phone. It doesn't matter. As long as we have something. I'm trying to delete the first here. Okay. And at this point, I'll hit save location. Okay. And I'll go ahead and play through because I know we've already seen this. My bigger concern now is to look at DDMS. So I go back to DDMS, and we know we can simulate the GPS location, send that to the phone. We know we can look at files on the file system and save them to our disk, and we know that can be very handy. Other things we can do, we can also simulate a phone call, or I'm sorry, we can push a file onto the device. We can also do things like simulate a phone call and get a screen capture of what's currently on the screen. We can simulate a picture. I'm sorry, so there's the screen capture right there. We can take that, okay, screen capture, okay, and there we go. See what it does is it just captures the screen at that point in time and makes it available to us so we can save it off somewhere if we wish. So lots of good development tools. Okay, we're almost at the hour mark, which is dangerously late for me to be recording something. So, a quick summary of what we did. We looked at the SQLLite Open Helper. We looked at the onCreate method. We quickly looked at onUpdate. We looked at get readable database, get writable database. We looked at the SQLLite browser, which either I'll put on Blackboard or you can just search for it and find it. We looked at what the DDMS can do. Okay, all of these would make wonderful quiz question suggestions. And honestly, I forget what quiz question suggestion we're on at the moment. I think number 6. So these would all go great under 6, or if I make a 7 or a... Actually, this would go great on the exam, 6, or our final quiz. So any of those, this would be great. I'm sure you'll probably end up using SQLite, so I hope this helps. And also, don't forget smart ways to handle exceptions. Exceptions seem annoying, but trust me, exceptions are gifts. They help us think of how to handle situations and still give the user a nice user experience. I want to cut this off since we're at an hour. I might do a quick follow-up lecture, 15 minutes or less, that just shows how to fetch, make sure our fetch works, and display those specimens on a screen. So I'm going to cut this off now and save it, and then I'll do a quick follow-up lecture that will show how to fetch data out of the database. Thank you.